In these questions, we know that waiting time is normally distributed. However, the mean and standard deviation is not known. So in question A, we are supposed to find out the mean and standard deviation for the waiting time. We know that X is normally distributed, and we know 5% of the time waiting time is less than 55 minutes. So we have a probability of X less than 55 equals to 0.05. Now we need to convert X score to Z score because mean and standard deviation for X are not known. Then we can use inverse normal by key in 0.05 as area and 0 and 1 for mean and standard deviation respectively. So we have a value of negative 1.64485 from the calculator, and this value equals to 55 minus mean divide standard deviation. So this is our first equation. We also know that there is 13% of chance that waiting time is more than 100 minutes. So we have a probability of X more than 100 equals to 0.13. We know that we have to use area on the left-hand side of 100 instead of area on the right-hand side of 100. So this gives us probability of X less than 100 is 0.87. Again, we need to convert X score to Z score because the mean and standard deviation for X are not known. Now we can use inverse normal by key in 0.87 as area and 0 and 1 for mean and standard deviation respectively. So we get a value of 1.12639 from calculator, and this value equals to 100 minus mean divide standard deviation. So we have second equation. Lastly, we need to solve the simultaneous equation to find the mean and standard deviation. So we can use CAS calculator to do that. So we can solve the equation by key in the following command. And finally, we can get a mean of 81.71 and a standard deviation of 16.24 minutes. In part B, we need to determine the probability that the waiting time will be between 75 and 90 minutes. So from part A, we have calculated the mean and standard deviation. So we know that X is normally distributed with the mean of 81.71 and a standard deviation of 16.24 minutes. So we can find out the probability that the waiting time will be between 75 and 90 minutes by using a normal CDF. And this gives us a value of 0.3554.